Okay, for 2-3, I'm going to go ahead and split 2-3, guys, into two parts because there's a lot of information there, and I don't want to jam you up with too much information, okay? So what we're going to be talking about is linear functions in slope-intercept form. Now, the first question that should come to your mind is, what is rate of change or slope? First of all, guys, rate of change and slope are the same thing. Rate of change just has units. Now, when you think of slopes, okay, I like to always think of a ski slope. If anyone has ever been skiing or tobogganing or what is that cool thing, snowboarding, okay, don't you go down the slopes? Now, when you're going down a slope, you're going a vertical distance and a horizontal distance. Because if you're here and here's the mountain, okay, and you start going down, you really started here horizontally, correct? And you went horizontal and you went down, correct? A vertical, correct? So that vertical change over a horizontal change, that is your slope. Slope, or rate of change, is the ratio of the vertical change over the horizontal change. The only difference between slope and rate of change is that rate of change actually involves units. Okay? Does that make sense? Okay, that the rate of change only involves units. The slope does not. Now, slope. Slope or rate of change is the same formula, okay? Slope equals rise over run or fall over run. Nobody ever teaches the fall over run, and then when people have negative negative slopes, they get all confused. You rise if the slope is positive. You fall if the slope is negative. You always run to the right. All of that will come into play in a few minutes. Slope is represented by the variable m, lowercase m. Please do not put a capital M, for that equals something different in mathematics. That equals the midpoint. So lowercase m is slope. And it's the vertical change over the horizontal change. Well, yesterday we talked about the x and y axis, correct? And yesterday we said the x-axis is the horizontal and the y-axis is the vertical. So we have vertical change, y2 minus y1, over horizontal change, x2 minus x1. Now, popular question, what is x1, y1 to begin with? Well, x1, y1 is just your starting point. I like to choose x1, y1 as the furthest possible point to the left, but x1, y1 is any point. You can choose any point for x1, y1 as long as it lies on the equation. And then x2, y2 is any other point on the line of the equation. Okay, that's all I'm talking about. So, for example, if I have this here, I have a line, okay, and this guy here, let's just say, is -3, 2, and this point over here is 5, 7. I like to call the points furthest on the left x1, y1. So this guy right here would be my x1, y1. This is another point on the line, so that would be my x2, y2. Now, I could have called this x1, y1, and I could have called this x2, y2. What you cannot do is mix and match. You cannot say, oh, the 5 is x1, but the y I'm going to call it y2. You cannot do that. You choose one as x1, y1, and the other one you choose would be x2, y2. Does that make sense? Okay. Now, let's find the rate of change. Please remember that rate of change. Okay, sorry about that. Okay, example 1, find the rate of change. Please remember that the rate of change is same as slope, except it includes units of measurement. So, remember to always find the independent and dependent variables first. Then label your x1, y1 and x2, y2. In this case, time is the x, or the independent, and distance is y, or the dependent. Time is always independent, by the way. Always. And of course, distance is going to depend on time. The longer time you walk, the further distance you go, correct? So, we know that time is x and distance is y. This is the first point I see, so this is my x1, y1. Second point I see, x2, y2. So I've got y2, which is 520, minus y1, which is 260, right? Over x2 minus x1. So that's going to equal 520 minus 260 is 260 over 1. But it's a rate of change, so I must include the distance. What this means is that I am increasing 260 feet every 1 minute. If it says rate of change, you have to have the units. If it's just slope, you will not necessarily have to have the units. And then I just put it here nicely for you, but we already did it. Does that make sense, gentlemen? Okay, pretty simple, right? And you saw this last year, correct? And you saw this in 7th grade, didn't you? Yes, you did. Yes, you did. Trust me. Okay, now, regardless, you saw it last year, and now you're seeing it again. So, we need to focus and pay attention. Now, what is the slope of the line that passes through the given points? Okay, this is very simple. I have 2 points. I'm going to name one. I have to. Name one x1, y1, the other x2, y2. I don't care which ones you choose, but you got to choose. So I'm going to choose this is x1, this is my y1, this is x2, that's y2. y2 minus y1 over x2 minus x1. Please be careful there. Remember the formula is y2 minus y1 over x2 minus x1. So it's the value of y2, which is 4, minus the value of y1, which is 7. Then x2, the value of x2, which is negative 2, minus the value of x1, which is negative 3. So please be careful there. That's going to give you negative 3, and negative 2 plus 3 is 1, so negative 3 over 1. I don't have to have units because I was not given units because I'm asking for a slope. Now, let me show you what happens, guys. This is a good trick to remember when the y's are the same. When the y's are the same, okay, you're going to have always what's called a zero slope. And I'll prove it. y1 minus y2, well, x1, y1, x2, y2. y1 minus y2 minus y1 over x2 minus x1 is 0 over negative 7, which equals 0. When your slope is 0, I'm going to give you a little heads up. We're going to go ahead a little bit. You can immediately write the equation of that function. What's happening here is that in this particular function, what's constant here is the y value, correct? So what's happening is there's a straight line going through that one value on the y-axis. So when the y's are the same, not only is the slope going to be 0, okay, guaranteed, but the equation of the graph is going to equal that value itself. So that's a lot of awesome information you can get from that. Vice versa, when the x's are the same, what's going to happen is always, and I'll prove why, the slope will be undefined. Undefined. Y, that means 0 is going to be in the denominator. Well, x1, y1, x2, y2. y2 minus y1 over x2 minus x1. That's going to be 4 over 0. That cannot be. That is undefined. Whenever you have a slope that is undefined, you can immediately go to the equation as well. Since the x's are the same, what's happening here on this graph is that here at the 7, I have a straight line going down. Whenever I have an undefined slope like that, I can immediately say that the equation for this is x equals the value of the repeated x. And then I threw in some fractions just because I know you love fractions. You got to do it. You got to know how to do it with fractions. x1, y1, x2, y2. y2 minus y1 over x2 minus x1. Well, here, guys, I'm going to make my life easy. Common denominator is 3. That goes to 9. That's negative 8/3 over. That goes to 5. That's negative 20. So that's negative 22/5. This is going to then be stay, change, and flip. So my answer here will be negative divided by negative is a positive. So it's going to be 40/66, which equals 20/33. Please be sure to review your fraction skills. This is very, very difficult if you don't know how to add, subtract, multiply, or divide fractions. Okay, so that's how you find slope when they give you 2 points. Very simple. You use the formula, you find your slope. What happens when they give you a graph or a line? Well, first thing you got to do is find an exact point. Now let me explain what an exact point is, guys. See here where you have a cross, okay? Right at the cross is the point. This is not a point. It is technically, but it's not going to be a point for our graphing purposes as far as finding the slope. This is a point, but not a perfect point. This is a point, but not a perfect point. What's a perfect point then? Here, where the crosshairs meet. Here, where the crosshairs meet. Here, where the crosshairs meet. You guys play all those little ridiculous games of shooting people all the time, right? When you have a sniper, right? Where do you put the head? Right in the middle of the crosshairs, right? Well, just pretend you're trying to snipe these, okay? Right in the middle of the crosshairs. That's the perfect point. So what you do is you choose a perfect point, which I already have it for you. It's right here. There's a perfect point. And then the other perfect point is right here. The other ones may seem like they're perfect, but when you're looking at the video, you can see it up close. You'll see that they're not. Now, how does this work? Okay. You always read slope, whether it's going up or down, from left to right. And remember that when we're dealing with slope, we're talking about a rise or a fall over a run. Right? Over a run. So, from here to here, what did I do? I went up 1, 2, that's my rise, and then I ran. You always run to the right. 1, 2, 3. So what's my slope? 2/3. Over here, perfect point is right here. Another perfect point is right here. How do I get from this guy on the left to this guy on the right? Always left to right. I went down 1, 2, 3, 4. Down 4. That's my fall. And I went over 1, 2, 3, 4, 5. I always run to the right. That's my run. So my slope is -4/5. Yes, no, maybe, kind of, sort of. Yes, sir. I don't like to teach run and then fall because then people put run over the fall. So no, always stick to rise over run. That way you remember always that it's rise or fall over run. Thank you. Good question, sir. That makes sense. Okay. Now, there are 4 kinds of slope, guys. Positive slope, if I'm increasing from left to right. Remember, big on left to right here. Negative, if I'm decreasing from left to right. Zero slope, that's the one that's a horizontal line. Remember, the equation for a zero slope is y equals a, where a is the value that it's going through. So in this particular example, this is 1, 2, 3, 4. So that's going through the 4. So this equation will be y equals 4. And the slope is 0. And then the last kind of slope is undefined. Undefined means that there is no run. The denominator is 0. It's undefined. It's a straight line going up and down. You can also get the equation for this guy when the slope is undefined. It's x equals a, where a is the number that the line is going through on the x-axis. In this particular case, this is 1, 2, 3, 4, 5. That's 5 there. So x equals 5 when the slope is undefined. Those are only special cases for the undefined and the slope. Okay? To find the equation of a graph, other than those two, it's a different procedure. So that's slope in a nutshell. It's pretty simple. Now, graphing linear equations. A linear equation or function is an equation where x has the power of 1, guys. If you have y equals x squared plus 2, it's not a line anymore. That's called a parabola. If the x has a different power other than 1, then it is not linear. A linear equation or function produces a straight line. If your line is not straight, then you made an error. There are 2 methods for graphing. We are not going to use method 1, but I got to do it just to be a good teacher to show you what the heck to do. Method 1, table method. Simply create an x and y table and choose values for x. This is the independent variable. So that's why you could choose the values, because they're independent. Then evaluate the function for the values of x that you have chosen. I like to use the moral 5, which is -2, -1, 0, 1, and 2. They're the easiest numbers to work with, so that's what I usually use. Then graph the ordered pairs and draw the line. Okay. Well, when x is -2 and you evaluate, what does that mean? What does evaluate mean again, guys? When you plug it in, okay, you're going to get -4 minus 5, which is -9. Yes, sir. You can use this technique if you want to, but you're never going to finish the test, so no. I'm just teaching this to you in case we get to a complicated equation one day, maybe, with like, you know, x cubed or something, and you don't know the procedure. You can always make an x and y table because x is independent and you can plug it in. When x is -1, we've got, oh, actually, that's wrong. That's -7. Oh, that's -7. My bad. When x is -1, it's -2 minus 5, which is -7. Hello, doofus. When x is 0, y is 5. When x is 1, 2 minus 5 is -3. When x is 2, 4 minus 5 is -1. And now we graph it. -2, -9 is right here. Come again? Yes, sorry. -2, -9 is down here. -1, -7 is right here. 0, -5 is right here. 1, -3. And 2, -1. You need at least 3 to 5 points when you're graphing a line. And that's how you graph, using the table method. We are never going to use the table method for the most part. Especially, let me rephrase that. For linear equations, you will never use this. Okay, for linear equations. It's just too easy. Too easy. So what we use is something a little bit more sophisticated. called the slope-intercept method. And the slope-intercept method is y equals mx plus b. Y is the dependent variable. M is the slope. X is the independent variable. And b is the y-intercept. The y-intercept, boys, is the y value on the x-axis when x equals 0. Here is how it works. First of all, solve the equation for y. In other words, you want to get y all alone in the form of y equals mx plus b. Number 2, identify and graph the y-intercept. That's the y value when x is 0. That's why I put this 0b. Okay, that's what the b is, the y-intercept. It's the y value when x is 0. And then 3, from the y-intercept, follow the slope for 3 to 5 points, going both forwards and backwards. This is my favorite thing to do in math. I absolutely love this because it's just so darn easy. All right, boys. For example, number 1, are you already solved for y? Are you already solved for y? Okay, thank you. What is the y-intercept here? Right, think about it. That's the b, isn't it? If I cross this out, isn't that the b? Okay, also, if x is 0, what's the y value when x is 0? 1, right? So instead of having to go through all that, it's really good just to recognize, okay, my y-intercept is 1. So I graph it according to my directions. What's the slope here, boys? 3 over 1. Good job for those of you who said that. Great job. So is that going to be positive? Am I going to rise or fall? Okay. Do I run to the right or to the left? Okay, so I'm going to go up 1, 2, 3, run 1 to the right. Up 1, 2, 3, run 1 to the right. Now let's go backwards. When we're going backwards, that's the only time you go to the left. So you would go down 1, 2, 3, over 1 to the left. Down 1, 2, 3, over 1 to the left. You always want to have both sides of the equation, the positive side and the negative side. Next, I got 5x minus y equals negative 3. Is that already in the y equals format? So I'm going to subtract 5x. Remember how I told you guys you will be solving for variables later on? We were solving literal equations. This is why we learned that skill. I got negative y now equals negative 5x minus 3. Divide by a negative 1, gentlemen, and y equals 5x plus 3. What's my y-intercept, boys? 3. So I graph it. 1, 2, 3, my y-intercept. What's my slope, gentlemen? 5 over 1. Great job. So from my y-intercept, I'm going to go up 1, 2, 3, 4, 5, run to the right. And I'm going to go backwards, down 1, 2, 3, 4, 5, 1 to the left. Does that make sense so far, gentlemen? Awesome. All right, let's continue. Okay, now in this case, this is quite funny. You have negative 0.2. 0.2? Can I work with 0.2 as a slope? No, how would you get a rise or a run with that? What can I convert that to? So what would the fraction be? Negative 1/5 or 2/10, which you reduce to 1/5. Always reduce. What's my y-intercept here, boys? 1, 2, 3. What's my slope? Negative 1/5. So I'm going to go down 1. And do I run to the left or the right? You always run to the right, no matter what, unless going backwards. So I'm going down 1 over 1, 2, 3, 4, 5 to the right. Down 1 over 1, 2, 3, 4, 5 to the right. Let's go backwards. Up 1 over 1, 2, 3, 4, 5 to the left. Does that make sense? Boom. Done. Here, what's my y-intercept? Negative 2. So I go to the negative 2. What's my slope? 3/5. So I go up 1, 2, 3, run to the right, 1, 2, 3, 4, 5. Let's go backwards, down 1, 2, 3, over 1, 2, 3, 4, 5. Is that making sense? Okay, some special categories. We already saw this, didn't we? Y equals 4. What kind of a slope is a y equals 4 line? Zero slope. What kind of a line is it? Horizontal or vertical? And it's going through the 1, 2, 3. It's going through the 4 on the y-axis. Beautiful, gentlemen. Same thing for the x. Is it a horizontal or vertical line? Vertical line, and it's going through the -5. So I go 1, 2, 3, 4, 5. It's going down right there, -5. Last two, just to make sure we get good practice. What's my y-intercept? So I go 1, 2, 3, 4, 5. I graph my y-intercept. What's my slope? -2/3. So I go down 1, 2, run to the right, 1, 2, 3. Down 1, 2, 1 to the 1, 2, 3 to the right. Backwards, up 1, 2, 1, 2, 3 to the left. Last but not least, I got to solve for y here. So I got 3y plus 5x equals -12. Subtract 5x to both sides. 3y equals -5x minus 12. Divide by 3. Y equals -5/3 x minus 4. Y-intercept is 1, 2, 3, -4. Slope is down 1, 2, 3, 4, 5. Run to the right, 1, 2, 3. Or go backwards, up 1, 2, 3, 4, 5. And then go to the left, 1, 2, 3. Remember, you always run to the right unless going backwards. May God bless you. I hope you had a good lesson. I'll talk to you on the flip side. Bye.